Hello everybody, get ready to do lesson 3.5 part 3 of pre-calculus math today. Email me here for questions or course materials. 3.5 part 3 exponential logarithmic functions.
Solving
You got 48 points here for classwork
function,
and 2 points here of notebook taking. Okay. Teachers, today's bell work. Use the leading coefficient test to determine the right-hand, left-hand behavior of the graph of the polynomial function. 10 points here, students. You have 5 minutes to do this. Okay, welcome back for the solutions of today's bell work on our leading coefficient test. For the graph rises to left and then falls to the right, so it goes like that. You have a negative leading coefficient here, and you also have an odd degree on your leading coefficient, on your leading variable here. So the graph rises to the left and falls to the right. And then the second one, the graph rises to the left and rises to the right. So you have an even degree here, and then you have a positive coefficient. So the graph rises to the left, and rises to the right as well. So it goes like that, something like that. Okay, into our first page here of our lesson today. Spread of a virus, example 5. Go back to our virus problem from part 2. So we got 5,000 students. Here's the function for that, where y is the total number after t days. The college will cancel when 40% or more of the students are infected. After how many days will the college cancel classes? So classes are canceled when the number of infected students is 0.4 times 5,000. So what we need to do is make this equal to 2,000, and we'll solve for t. So when we do that, we have 2.5. We move this over here, move this over here. So they have 1 plus 49.9 e to the negative 0.8t equals 2.5. And we move this over here, so it becomes 1.5 over 4.9999 e to the negative 0.8t. And then we're going to take the natural log of both sides. When we do that, we have negative 0.8t equals natural log 1.5 over 4999 t. Now when we divide both sides now by negative 0.8, we crank that out, we get 10.14. So our time will be after 10 days. You'll have at least 40% of students will be infected and classes will be canceled. So that would be how you would solve that. So let's use the graphing utility to graph that. So this will be the graph here. This is your logistic curve like this. And then your straight line here is a student amount of 2,000. Y2 equals 2,000 would be that. And then this curve will intersect that horizontal line at 10.13941 would be how you would solve that. Using the intersect feature of the graphing utility, the intersection occurs at the point 10.14, which is about here. So after about 10 days, at least 40% of students will be infected, and the classes will be canceled after 10 days for that one. Let's try one now. A conservation organization releases 100 animals of endangered species into a game preserve. The organization believes that the preserve has a carrying capacity of 1,000 animals and that the growth of the herd will follow a logistic curve here. What is the population after 5 months? So we did something like this, very similar in part 2. So after 5 months, you'll have 203 animals using this function here. After how many months will the population reach 500? So now we make 500 equal this function here to solve for t. And what we do, we move this over here, and then move this over here, and then we move our 1 over here, then we end up with this here, 9e, then we divide through by 1 over 9, and then t would equal negative natural log 1 over 9 over this amount. We get 13 months when it will get to be 500. We might even have done this in part 2, but in a way it's a good review to do this again, to actually do the same problem again. And then to graph that issue here, yeah, it certainly does look familiar. So we did this in part 2, we're doing it again here in part 3, and then this is where the line flattens out there. So horizontal asymptotes are 0 and 1000, and it will eventually reach 1000 at that designated time. Your notebook entry here, logarithmic models. On the Richter scale, the magnitude R of an earthquake of intensity I is given by here. So log base 10 I over I naught, which is the beginning, where I naught equals 1 is the minimum intensity used for comparison. So I naught is just another way of describing 1. Used for intensity is a measure of the wave energy of an earthquake. So it's kind of like a metric used for wave energy earthquake. So magnitudes of earthquakes are, in 2009, Crete, Greece experienced an earthquake that measured 6.4 on the Richter scale. Also in 2009, the north coast of Indonesia experienced an earthquake that measured 7.6 on the Richter scale. Find the intensity of each earthquake and compare the two intensities. So we're going to compare these two earthquakes now. And then here is our function here to measure wave intensity. So I naught equals 1 and R equals 6.4. You have 6.4 equals log base 10, 1 over I. So we're trying to find I here. So we're going to jump things up by exponentiating 10 to the 6.4, exponentiating this sign, 10 log base 10 I. And then that'll give us 10 to the 6.4 equals I. And then for R equals 7.6, so for the 6.4, that is your I. For 7.6, you have 7.6 equals a log base 10 I over 1. And then when you solve this one, you'll have 10 to the 7.6 equals I. So that would be the way that you would measure wave intensity. So the Richter scale does have some logic to it when you're trying to find for it. Note that the increase of 1.2 units on the Richter scale from 6.4 to 7.6 represents an increase in intensity by a factor of 16. So when you divide 10.76 by 10.64, you get 10.12, which is 16. So just because it goes up 1.2, it actually intensity is a exponential factor there. So the intensity of the earthquake near the north coast of Indonesia was about 16 times as great as the intensity of the Greek earthquake. So let's try one now. We got Haiti at 2010, Richter equals 7.0, and then Samoa Islands 8.1 and 6.1 Virgin Islands. So find the intensities I of the following earthquakes. So to do that, here for the Haiti, here is our method here of finding our intensity. 10 to the Richter will give us our intensity. So it'll be 10 to the 7, which is actually this pretty large number. Intensity equals 10 to the 7. And I'm going to let you do yours. I'm going to let you do those on your own. So let's go into our example 7 here, pH levels. Acidity or pH level is a measure of the hydrogen ion concentration, H+, measured in moles of hydrogen per liter of a solution. Use the model given by pH equals negative log base 10 H+ to determine the hydrogen ion concentration of milk of magnesia, which has a pH of 10.5. So write your original model. We're going to make our pH 10.5. We know our pH here of milk of magnesia 10.5 equals negative log base 10 H+, and then multiply each side by negative 1, so we get rid of this negative log over here and bring it over there. And then when we exponentiate each side, 10 to the negative 10.5 equals 10 log base 10 H+. Once we do that, we get 3.16 times 10 to the negative 11 equals H+. So the hydrogen ion concentration of milk of magnesia is about 3.16 times 10 to the negative 11 moles of hydrogen per liter. So that would be how many moles of hydrogen, which is a fairly small amount of hydrogen ions per liter. So let's try one here. Use the acidity model given in example 7. So find pH when H+ equals 2.3 times 10 to the negative 5. We're going to go reverse on this one. Then compute H+ for a solution in which the pH is 5.8. So let's try this one first up here. So our pH is negative log base 10 H+, which equals negative log base 10, 2.3 times 10 to the negative 5. And when you crank this out here, you'll get 4.64 as your pH with this amount of hydrogen ions per liter. And then down here, the compute H+ for a solution in which pH is 5.8. So 5.8 equals a negative log base 10 H+. We know our pH is 5.8. So we make that equal when we exponentiate both sides here. 10 to the negative 5.8 equals H+. Then H+ equals 1.58 times 10 to the 6. We're going to round up to 10 to the negative 6. So basically, when you do that, you come up with 1.58 times 10 to the negative 6 moles per liter. And that is your 3.5 Part 3 lesson of pre-calculus math. Email me here for questions, homework sheets, classwork sheets, tutoring, etc. Thank you very much.